Grade 12s, this is Analytical Mechanical 4. We have a front view and top view of a micrometer, sections, a part list, a title block and a table of questions. The drawing has not been prepared to the indicated scale. You have to look at all the questions from 1 to number 20 and retrieve the questions from the accompanying drawing on your left hand side. Let's start with question number 1. Who prepared the drawing? And that would be Wendy, who drew it right here at the bottom. Question 2. On what date was the drawing checked? The date was the 10th of the second month, which is February 2018. What was Siyabongi's responsibility? Siyabongi approved the drawing, and that was the date. Number 4, what is the drawing number? Drawing number MC25-V 2018. Question number 5. What material is used to manufacture the anvil? So that material, according to our part list, is tungsten. How many parts make up the micrometer? Once again, to our part list, there are 8 different parts which would be assembled to make up the micrometer. Number 7, at what temperature will the micrometer be accurate? Learners, the accuracy of the micrometer will be at 20 degrees, and that's in your title bar. Question number 8, what is the maximum size that this micrometer can measure? So the maximum is indicated here with the measurement range, and the minimum is 0,01 and the maximum is 25,00. So that would be 25. Number 9, why is the shaft at A drawn as a phantom line, a double chain line basically? A phantom line is an imaginary line. So we're looking specifically at this here, this component, which is seen from the top, and this is the front. Basically, it's a component that's not really there. So it's just representing the component that's not really there. Question number 10, what does the S break at B indicate? This is the S break here, and that's also a representation of the S break. It means that that shaft actually continues both to the left and right, and it's longer than the required shape that's drawn on the page. Question number 11, give 2 uses of chain lines on mechanical drawings. Learners, chain lines are lines that have a definition of a long, short feature, and we have a number of chain lines on our drawing representing different things at this stage. So it could either be the center of circles or arcs, or it can be shafts, the center of a shaft which we have here, or it can show symmetry where the one side is exactly mirror imaged as the other side. It can also be PCD, position, or simply a cutting line which you have here, but then it will have arrows both at the one side and the other side. Number 12, how many surfaces of this micrometer are knurled? So if you examine the micrometer, you will find these are null links which we have here. So one knurling, another diamond knurling, and a third one. So that would be 3 knurlings that you will find on this micrometer. Question number 13. What is view 1 called? View 1 is that view over there. This is the front view. Because the drawings are in third orthographic projection, that view 2 will be your top view of this front view. So view 1 is your front view. Number 14, we need to determine the complete dimensions at C, D and E. Let's go find C, D and E and fill in the dimensions. Learners, if you look at C, it refers to the dimensions from the one side to the other side of your micrometer. And you have the sub dimensions here. So you're going to add 16 plus 46 plus 19. And then you're going to look at this radius here, which is the far side. And I'm referring to this radius here on this side here. And that radius is going to be 29. But this is the radius, so it's from here to there. So we have two 29s there, plus the 19, plus the 46 and the 16 will give you 139. And that we're going to write in by C, 139. And then we look at D. So grade 12, you look at D. D is a little bit complicated. So what you need to do is you need to find the distance from here to there, which is going to be 29 this side and 29 that side. And that is going to give you 58. Then you need to subtract this amount here, which is going to be 5. You need to subtract this amount here, which is going to be 10. You need to subtract that amount there, which is going to be 3. So we have that point over there. And then you also need to subtract this 15 over here. And you need to subtract that 9.15 that you have there. The 1 millimeter that you see here makes up for the 1 millimeter that you see here, which basically cancels out. And altogether, you're going to find an answer of 15,85. So that here is going to be 15,85. Now, if you look at E, E wants the diameter of that part there. That part there is section TT, which is that cut section here. There's no dimension given here, but if you go to your front view, you're going to find that that diameter 18 refers to that piece of cut section through this knurling here. So your answer is going to be diameter 18 for E. Question number 15, measure the angle at F. So we're going to look at this angle that you will see here. So you perhaps will have to extend that line there to get a perfect angle or an accurate angle dimension. And you're going to make use of a protractor, which we have here. So you are going to place your protractor perfectly on that point there where the two lines meet. And you're going to line this bottom of your protractor up with that line, and you're going to see where this line strikes. And you will find it strikes perfectly through 84. So that is going to be an 84 degrees that you will see there. We're looking at number 16, number 17 and number 18. Name the types of section at G, H and J. So if you look at G, you will find that the shape of the sectioning lies inside the component. So that makes that a revolved section. If you look at the next one, which is going to be H, H has a wavy line there, so that is going to be part section, because the wavy line is normally associated with a part section, and the part that we need to show would be that part there. And then J refers to these three components which were taken out, so it can either serve as a remove section or a successive section where it is successively cut, S, T and U. Both answers will suffice. Number 19, with reference to the tolerance at K, and we need to find K on the drawing, determine the minimum dimension. Let's go find K. So K refers to the 3, and we have the upper and the lower tolerance here. So we want the minimum, which is the lower tolerance. So we are going to say 3 minus 0,1, and that's going to give us an answer of 2.9 millimeters. You're going to write the answer in the answer block. Question number 20, and the final question. In the space provided here, draw in freehand the symbol for the projection system which was used. Learners, this is a very popular question, and we're going to have our crossing and our center line firstly, small circle, big circle, representation of the small circle, representation of the big circle, and the adjoining lines that you will have on a slant, which forms your third angle orthographic projection symbol. Learners, thanks so much. This concludes the analytical mechanical chapter.